coming to the MLOps infrastructure piece, I don't want to call it MLOps. We spoke about large vision models, which is not a terminology that is publicly available. And how do one go about identifying these requirements for infrastructure?
So I think it's a $1 million question specifically for enterprises to be, which is the CPU and the CPU RAM before is no more relevant if you want to operate in the GenAI world today. It's very, very interesting to see that GPUs, which have very less instruction set,
The question that I wanted to ask you is, Jenna, as we have matured during the last 5 years, we have seen small clients, smaller data, medium-sized clients, medium-sized data, larger clients, large-sized data, and everything. And like you mentioned earlier, every engagement has been a learning thing. And like DJ pointed, no, there is no one-size-fits-all kind of an approach. But coming to the MLOps infrastructure piece, I don't want to call it MLOps, but I'll keep it generic for the sake of our audience and keep it as infrastructure. Now, when we spoke about this healthcare client, we spoke about large vision models, which is not a terminology that is publicly available, unlike large language models. Actually, this is a terminology I heard only from you, as to maybe there is something out there, but I've not seen anything. But I heard it only from you. Now, in the past, when people talk about data, processing data, and things like that, common terminology or names like big data, Apache, Hadoop, and all that is something that all of us have heard. But is that infrastructure still relevant to process large, images, larger sized documents, content, and things like that, or the nature of infrastructure requirements have changed with respect to these kind of models that we're talking about, like LVMs and things like that? And I wanted to understand your perspective in terms of how do one go about identifying these requirements for infrastructure. How can enterprises prepare themselves to build such infrastructures before they actually get into the journey of artificial intelligence? If you can enlighten us.
Sure. Thank you. Thanks. So I think it's a $1 million question, specifically for enterprises to pay attention to. Probably people who have aspirations to be part of teams that build infrastructures like this too. I don't think the Hadoops of the world that were out there operating on top of gigabytes and terabytes worth of tabular data, if I have to qualify that way, will be relevant in the scheme of activating data from pixel-based assets. Let's say if in our line of work we get to receive documents that are PDFs in nature, PDFs that will have images in them. We also receive fax forms, which are PDFs, but they are not actually PDFs, they are actually images. If we have to do large-scale processing on such assets, the older manifestation of big data architecture in the form of Hadoop will not help us. That is, I don't want to get into the technicalities of it. Hadoop as an infrastructure is built on top of Hadoop file system, and Hadoop file system has its certain design considerations that are not suited well for kilobytes and megabytes worth of files that are millions and probably hundreds and millions in number. So having offered that context that Hadoop will not work, but even by the time Hadoop was out there, people used to call that big data is not technology, big data is architecture. How do you design systems that will enable you to scale out and scale up systems that will help you to continue to keep your operational expenditure low, but have the ability to process large volumes of data? If we have to borrow from that, yes, we have to think the big data way, even to solve the healthcare companies problem that we have. So I don't think I remember the exact numbers, but on a given day, the company that with whom we are working right now, they probably receive somewhere around approximately 1 million papers a day. And in those 1 million papers, we need to find information in the right set of papers, extract them, and then hand it over to them, part of the workflow integration. 1 million papers compared to 1 million rows in a tabular form may look less. But just to give you some contrast, we are talking about an A4 sheet size paper which will have probably 1290 multiplied by 780 pixels. We're talking about 4 million pixels approximately for an A4 sheet size paper. So multiply 4 million with million.
Wow.
We have to process every single pixel to activate data. Even in technical parlance, we have to do full table scan on all the A4 sheet paper.
Yeah, the magnitude is like enormous.
Enormous. So the need to set up an infrastructure that will solve this problem definitely need to be borrowed from the big data principles that the previous
It has
generation
governed us in the past. Yeah.
exactly. So that is something that I will definitely present as my learning. And the other thing that is this has become a constant niggle. I don't think there seems to be no way out right now, which is what was offered to us as a commodity, which is the CPU and the CPU RAM before, is no more relevant if you want to operate in the GenAI world today.
Very interesting, because I'm sorry to interrupt you there. One of the questions I had in you imagine was, you spoke about GPUs but not CPUs. Is there a way for AI systems to rely on CPUs and run? Was one of the questions I had.
A lot of effort is going into small and large, but there is nothing that seems to be promising so far. Um, it's very interesting to see that GPUs, which have very less instruction set from a complexity standpoint, they are not as sophisticated as CPUs, but their ability to have pack large number of cores into them seems to have given answer. We would be surprised to know that GPUs are getting deployed to solve big data older world problems. Because what was supposedly deploying your software on hundreds and thousands of machines, what NVIDIA is saying is, if you want to process tabular data, use Apache Spark on top of my GPU, because whatever Spark needs to do, it will do much better on top of the thousands and 10,000s of cores that I offer, rather than you going after multiple machines. So NVIDIA has done this amazing trick where they are inviting older players who want to do big data processing into GPU world.
Something probably, if I'm not wrong, they retrospectively learned.
They got lucky. That's a different story altogether. And the reason why I'm saying this is, all said and done, we have to build big data infrastructure that knows how to put GPUs to use to do large scale image processing also.
Got it.
We can get into the technical details, but if I have to give a very simple explanation, borrow the principles of what big data had, but find a way to implement that on top of what can operate on GPU.
And those are the principles on which we have done
We
our
have done
implementations.
exactly. I think probably, would I be wrong if I say we may be one of the very few companies who have built distributed image processing systems for data activation.
Wow, that's a very important lesson.
Yeah.
And so far we have also not seen any of our customers for whom we have done these implementations complaining about infrastructure failing them or anything like that, as far as the models go.
Yeah.